Hello, testing. All right. Sounds good. All right, welcome everyone. Let me just send the messages out. And there we go. Yeah, hello. So I think we are back. It took quite a while. We were not streaming for, I think, almost 3 weeks now. Was busy with manufacturing and this kind of stuff. We will try to do some streaming today and assemble more of the fx2grok stuff. Let me just check that everything is running smoothly. Yeah. YouTube, there we go. So today we also are streaming on Twitch. Let's see if that works. Yeah, there we go. So, hi, long time no see. As you might remember, we were streaming about fx2grok and its assembly, and just let me show you something. I received the boards that Uwe designed, the version 1.0.1. So this is the tiny board. Hope you can see it. So what it turns out, Uwe made a slight mistake when designing the board, and the footprint of the FX2 chip was numbered in the wrong orientation. So it was going clockwise instead of counterclockwise, the numbering of the pins. And this board will not work. So I didn't come around to assemble this to figure it out myself. So Uwe warned me that it is wrong. So he designed a new version. There is version 0.2 of the fx2grok Tiny. And he will... I should probably order one of those boards too. He ordered already a bunch and he will be testing them, but I didn't come around to order them yet. What I did order is some parts. Like one thing I wanted to show you is this really cool cable from Samtec. They're from the series called Emi. So Emi is like a special pin clamping system where they have several contacts instead of just two usually you have on this kind of connector. So there is the tiny connector. It has even retention and clips and everything. It's pretty cool. What the nice thing is about this, so if I show you some cables that I use for breakout. So usually, so what I ordered at some point for JTAG breakout is this cable that has nice small connector on one end, and then it breaks it out to the 0.1 millimeter or 0.1 inch pitch. So it is 2.54 millimeter pitch connectors, so you can just connect it any way you want. The problem with that is the ribbon cables, if you split them apart, this stuff is quite fragile. It's still very useful and works very well, but compared to this, it has the same pitch on one end, and And then it has these wires that are actually crimped and plugged into the connector. The nice thing about this is it's more sturdy, it's more stable. So what we will do is crimp connectors on the other end and basically make something like that. And then we have a very nice compact connection for having the logic analyzer connected. If I find what we usually have, yeah, normally you have just the 0.1 inch pitch or 100 thou pitch connectors on both ends, and this makes it easier, but it is not very compact. And I like things that are nice, tidy, and small. So. Anything else? As I said, we are now streaming on YouTube and Twitch, and I hope both things work. And you will be able to find me there. If you have questions that you would like to ask me while I'm streaming, the best place is gitter.im/Esden/live. This should be listed in the chat on the side. So if you have questions, just ask me there. I will try to keep an eye also on some other channels like Scanline Live on so I can recommend watching all the streams that Micah Scott does. You should go there. She's amazing and really smart engineer, and she's streaming all the time and showing her process. It's very impressive stuff. So if you are here and you don't know about her channel, you should definitely go there. She's a major inspiration for what I'm doing here. If you look at the chat on the side, it's actually her style sheet that I stole and used for my use. So thank you for that. Alrighty, so let's get going here. Let's see if this is the correct setting. Yep, so this is KiCad, and where did we leave off last time? I didn't do much work on this. Mostly it was preparation and thinking about what the next steps should be. Also, I talked to Uwe quite a lot, and he had a bunch of additional ideas. So first of all, so I have a short to-do list of things to be done on the board. The only other thing that I also did, let me see, where is it? Yeah, so the board design, as you see, I deleted some of the traces because I was trying to figure out what the layout should be so that we can actually route it. And because I realized that as you might have seen in the previous stream, the problem was that if you have traces from the USB connector, they have to go to the side here. So this is where the signals go in. It's a little bit unpleasant. I wish they were just on the opposite side of the ports that we are using for the logic analyzer part. Yeah, so I was thinking maybe put it like at 45 degrees so that the connectors are pointing a little bit more to the left, as well as but then I would have to like go at an angle from the pins on the side here. That's not very pleasant. So I think this is a good compromise. I moved the crystal to the side, and we will probably be able to decrease the size of the board and compress it a little bit, so make it slimmer and probably shorter in length. This is because if you look at it, we have a ton of space on the board. We don't really need that. So that's one. That's what I actually did on the off stream. What we also got is quite a bunch of really good comments in the on YouTube from people that watched it, either were on the stream or watched afterwards. And one of the things that I got I didn't even know that they existed. It's like this is where when you learn EE on your own without actual background, you don't know a lot of things. So one thing I didn't know about is the existence of so-called filters. Let me see, where do I have it? I have it open somewhere. So this is the thing. If you go on DigiKey, there is Emi Rfi filters. So they are used for input outputs and IMI filtering. And these are integrated parts, and they have several parts already inside that we were putting discretely on the board for no reason. So what we can do is use this part that has, let me zoom in a little bit. Zoom. So this is what it is. So it has Zener diodes that will protect from a zap. Then it has an inline resistor. There are also others that use inductors instead of resistors. And it has built-in capacitors to basically have a frequency cutoff. The one that I chose, I think, is 100 megahertz. No, it's 100 kilohertz here. So that's weird, because I thought I chose something with higher frequency. Now I'm confused. Yeah, so it says here that it is 800 megahertz to 3 gigahertz. Attenuation value of 28 dB down. So yeah, I guess this datasheet might be the wrong one. Channel, this is the channel capacitance. Okay, fine, sorry, I should read the datasheet and everything. So yeah, these parts are nice. This will save us a bunch of space, and I actually got them already from DigiKey. I can show you. They're tiny little buggers. Filter it. There we go. Let's go here. So yeah, so they come on an 8mm white pick and place tape, and these things are really tiny. They are basically the size that my quad resistors are. So this will be nice. We will probably design the footprint for this and the schematic symbol and replace those. So that's another thing to do today. Simplify the front-end interface. And one more thing was, so what is also on the agenda is the PA 0 that we have in here. So PA 0, where the LED is connected, is very often used in other logic analyzers to have a relay connecting the analog input. If these are combined analog and digital analyzers, they have a relay that can switch between like different frequencies. Yeah. Hey Chris, nice to see you here in this channel too. Yeah, so yeah, they're designed. So Chris is saying that these are all-in-one ESD chips, are really nice, convenient for layout, and also perform much better than for ESD protection. That's my thinking too, because they are designed for the purpose, so they will be a perfect fit. I just didn't know that they existed. Now I know. So we will replace those. So if you know of any other things that we can make better in this design, do use a different integrated chip or something, please let me know, because I'm learning together with you. All right, so going back, PA0 is used for relays for the analog input, and so we will move it to PA1. And that is what Uwe did on his improved Tiny board. And then I realized that we forgot to connect the ground pad to ground. It doesn't have to be, so the die pad can be not connected, but for routing purposes, it would be nicer to be able to have this connected to ground and then be able to connect the ground pads here outside directly to the center pad. So this will basically save us a little bit of routing outside, or having to make sure that the ground plane outside is connected. And as you might see, it's quite tight in here. There is a lot of stuff going on. And so it will be nicer if we have it connected. Okay, then the front end, I already talked about that. Then we have also two more signals that I wanted to add. One is a trigger input and the other one is clock output. So trigger input, so first of all, the firmware that is currently part of Sigrok doesn't support this, but there are devices out there that have this connected and have it available. And this would be a nice thing to basically forward carry and have eventually implemented in the software. The trigger input is basically being able to tell the logic analyzer from the target that you're investigating when to sample the data. So that's very useful. And basically you can synchronize it with some data output or an external clock or something like that. And the other way around, you can have a clock out that will be able to be connected to the target and tell the target to synchronize the target and the logic analyzer. So especially in cases where there is a limited bandwidth of the logic analyzer and you're trying to read in data from or analyze something that might require quite a lot of oversampling, this is a useful feature to be able to sample higher frequency signals and not have to go with a logic analyzer that might not have that frequency available. So in our case, it is 25 megahertz maximum of sampling rate. So if we had something that was just on the verge of the 25 megahertz is due to Nyquist, you would have trouble sampling something close to that. All right, so these are the things that we wanted to do and work on today. So where do we start? I think let's start with the easiest thing and just rewire that LED. That's pretty easy. So first of all, I think what I will do is move this guy out of the way. Also, if let me know about the audio quality of the stream, because I decided to change things and use a compressor instead of just having a gain, and I'm hoping that it will result in a more even audio output to the stream. Yeah, so okay, so we moved this, we want to move this delete. And yeah, we should rename that. This is not PA0, this is PA1 now, and then there we go. All right, so yeah, I think this is better if we have it separately This will make it cleaner. All right. Can keep it close, but maybe we should just have it here and name it LED. It's pretty obvious. But I will want to have sections that are marked what section of the schematic is what eventually, so having the labels will be nice. Okay, that's the first thing checked off. Then the ground pad. For that, we have to actually edit the schematic symbol. So let's go to the symbols and oh yeah, so on the previous stream I have been asked how to actually add libraries to a schematic. So let me do that really quickly and show you. So if you have a library, yeah. So Chris is saying that I'm using the same convention as he does for different parts of the output signals. Yeah, I just decided that it was somewhat natural. I actually in one of the previous streams I was talking about how I did it in the Blackmagic probe, and there is I had actually 3 different labels to have it cascade through a series of passives. And there was a PB, so basically PB0, then there was XPB0, and then IPB0. So I think was the internal part, then the intermediate was just PB0, and then the external part was XPB0. So yeah, if going through the signals, the nice thing about using the labels at all is that in the PCB layout, the names are of the nets are visible, and you know what is going on and which part of the signal one is at. Yeah, it would be somewhat nice if there was a way of carrying over those signals through the net. Yeah, I don't know how. Yeah, the only thing is doing it manually, I think. Yeah, I can't think of anything better either, Chris. It's like, this seems to be the only way of doing it. Unless the KiCad would somehow like carry over net names through passives or something, but that really would be opening a really massive Pandora's box of how to do it, and everyone would complain that no, it is not the way I do things. And so yeah, it's probably up to us to figure out how to do it. Okay, so libraries. So libraries are in preferences, and then we have component libraries in here. So how I do it is add a relative path. If it is a local library to the project, then I have a relative path, and then you can add a library from that directory in here. And this is only for the schematic symbols. And what I didn't show is how to add footprints to the library. Oh my God, yeah, Chris, it's no. Yeah, I understand that programmers have all the text with it's just even more hideous. You also wouldn't if you had. So Chris is talking about the unfiltered to have a schematic net name to be fully spelled out and long and ultra verbose. In schematics and PCB layout, you can't really do that without it being super annoying, because if you look in the PCB, you want to see the net name on the pad. Imagine you had like a 30 character name of the net here. It doesn't fit. You want to be able to, on the first glance, have an idea where the signals are going. So no, not happening. So, okay. You're good at, these are good comments, Chris. So, all right. To add a library that is actually the footprint, that's a different story. And I think this is only in the preferences footprint libraries manager. This is where it is. So you have to go into the into PCB new and then add libraries in here. And what I currently have set up is global libraries, not project specific libraries. This is partly a problem if someone downloads my projects from GitHub, and I probably should change that and have just the local libraries in here. Hi David, welcome to the stream. Thank you for joining. So if the question from David is about the FX2 board. So it is a generic FX2 board, or mostly generic. It is based, so the whole schematic is a combination of what we quote unquote think is the best idea of having a device like that with a good balance of features versus non-features. It is supposed to be as generic as possible. It is supposed to be simple. It is supposed to be low cost, one-sided load, and pretty small. So this is the combination of features we are looking for here. But we can talk about, you will see down the road, it's like the special features here are just having the biggest superset of logic analyzer specific features of that FX2 logic analyzer board. And another big feature of that board, it's open source, so you can look at the schematic and the design files. You don't have that with, so as far as I know, there's only very few well-documented FX2 based logic analyzer boards out there. So this is what we are trying to do here and document the whole process. All right, so yeah, PCB library tables. We will, so I probably should rejig the things so that it is using the libraries that are from pretty KiCad libs. That is a submodule in the GitHub repository containing the design files to use the footprints from libraries that are linked as a project-specific libraries. I am aware that this is not perfect. So currently I have just in my projects directory, I have another clone of the pretty KiCad libs, and I link all the footprint libraries from there. So it's convenient for me. It's not convenient for you. I know that, so I have to fix this. So, all right. Let's see. So let me catch up on chat here. Yeah. Yes, so I'm seeing message from Chris. Yes, it's like we can have fully verbose text too. Oh, yeah, with 1, 2, and 3, it's like a series. Yeah, probably. That would be a solution. I don't know, it just didn't feel right. It's like the having I for internal, X for external, and then no name for just generic signals. That's how it felt right. But yeah, I guess one could just call it 1, 2, 3, 4, especially if there are more segments to it and you're trying to feed it through several parts and there is not really a distinction of external versus internal or something. So yeah, that might be a solution. If I run into that problem, I will basically blame you that it was your idea for the numbering, and I will use it shamelessly. All right. So, yeah, ground paths. So then we had the library. We had to edit the schematic symbol. So the schematic symbol, and we have the Scilabs. Okay. Then download That is wrong. Why is... I thought... Oh, it's Cypress, right? Cypress, yeah. There we go. So we need to add one more pin, and the pin will be 57. 57. Just call it pad. I'm lazy, just passive. All right, visible. Yeah, so pad should be fine and have it distinct. Yeah, that looks good. Let's save this. Yes. Okay. And this should update. There we go. The pad is updated. Now we can connect it. So the pad with number. Oh, interesting. This symbol has like extended connections here. Oh, this is some weird thing Uwe did here, I guess. That is strange. So these are longer pins and they are scooted into there. Okay, that is strange. All right. Should I change the convention here? I probably should. So these are all 3 long, but normally they are just 2 long. So we could make them all shorter or not. Ugh, I don't want to like redo the whole symbol now. Yeah, we just leave it. I might clean it up off stream or something to make them all like the 0.2 inch length. Yeah, whatever. Let's save this, create a net, generate, save, and we can net, read current net list, yes, and close. So see, now it is all connected to ground. Now if we rebuild the ground plane, yeah, so now we still have to connect this stuff to the ground plane here. But I will do this later because I might need to still move all this stuff around. And yeah, the names are too long now. Yeah. Don't make jokes like that. I might do things like this, Chris. It's like if you suggest things as a joke, I might take them serious. And then blame it on you. That's what will happen. All right. Yeah, so we have the ground connected. Yeah, let me disable this. So we have 2 to-dos crossed off. Oh yeah, and the LED should be connected now to PA1. Yes, it is. Good. So it was connected to 33, now it is 34. So that's better. All right, what next? Yeah, I was thinking about the trigger pin and the clock pin. Don't stop trolling the chat. It's fine. I enjoy it. It's good. Yeah. Chris, you have the permission from me to write weird things about KiCad in my chat. You have my permission. And also your opinions about how to do things in KiCad are greatly appreciated. All right, so yeah, we wanted to add clock. So before I do all the rejigging of the front end, which will be much more work, I think I will just add clock and trigger. Yeah, so trigger, according to Uwe, who checked a bunch of the boards he had, has trigger output connected to RDY0 or SLRD. So this would be this. Yeah, so Chris, it's too early for me to start drinking yet. It's 1:30 here. It's not beer time yet. I just had my coffee. I'm drinking my water. That's what keeps me alive. But yes, KiCad is an interesting piece of software. But it's getting better. Nightly builds. And thank you for your work, Chris. It's like, thank you for contributing a lot to KiCad and making it better. Because that's the only way of getting to a point where we all will be happy and don't need the alcohol to use it. Unless it is nitro fueled. Then crying it is, okay. Yeah, I will try to squeeze a tear. All right, so this will be trigger, and that will be connected to the output, but we will need a bigger connector for this. That's a separate story. And we need clock. Clock is connected usually to CTL1 or CTL2, and so yeah, let's connect it to CTL1. So Uwe told me that he checked on one of the boards and it was CTL1 for clock out, but he says he might have seen it also on clock 2. That's what I have noted here. All right. Should I call it clock out? Should just call it clock. Yeah, there we go. Yeah, so the problem now with the outputs is we are using currently the standard 10-pin connector that is also used by ARM Cortex. Yeah, I wanted to keep using that if possible, but if we want the trigger and the clock outputs also available, then we definitely need to use a bigger connector. The question is, do we want to use just a longer connector that has 2 more pins, or do we want to use something that might be useful further down the road that has even more pins and we just have not connected on them, so we can reuse cables and stuff like that from that version of the hardware for something in the future? Does it make sense? I don't know. The advantage of not using the same connector as the ARM Cortex is that it's basically distinct, and you know that it is not the JTAG connector. And if we are using the Tiger Eye connectors anyways, they are not compatible. Like the shroud is not compatible with normal JTAG connectors. So at the end, I think what we should do is actually use a specific one that will be right for this board and use an SMD Tiger Eye connector. And the sad part is I probably can't use this cable So there is your crying. Yeah, so yeah, we will change this. Yeah, we can just go here, and we can change this to be a 6-pin test. Yeah, now we have 2 more pins, and move. Yeah, so if we look on Samtec, we can go there and just spec what we want. So there are the T. Let's see if this is the correct thing. It's yeah, it's the half pitch and single row 50 pins, and then we can go here and have a double row and say we want 6-pin rows, and then we can see, yeah, this is how it looks. Oh, this is a, oh, that's an interesting connector. I actually didn't even realize. So this is actually a cable to pin header. Cool. It's not exactly what I wanted, but yeah, there is the Tiger Eye wire system. Yeah, so this is what the connector was. Yeah, but we will be able to spec a 6-pin connector here, and SFC Tiger cost-effective, reliable socket strip. Yes, so this is basically what we want. These don't have retaining clips usually, but we can just do this, go on 6-pin. The question is, what are the lead styles? Pick and place pad. Oh, this is that what it changes? Yes, so T2 is the SMD version. Alignment pin, locking clip. Yeah, pick and place pad would be something we would want. Tap in real options. Oh, so, and also this is the positive side. That's actually not what I wanted. Okay, anyways, I have to find the right thing if I want to make the footprint for this. Because I don't have footprints for the Tiger Eye stuff. That's why I'm here. Come on. Yes, Samtec website. A little bit over-engineered. Okay, what we want is... There we go, that's better. TFC. So that's the positive part. Let's see if that is what we want. There we go. So SMD part, 6 pins. Alignment pin option, locking clips, no. Pick and place pad. Oh, yeah, plastic. Let's see. Yeah, nice. The plastic pad. Yeah, the plastic pads are cool. I have something similar on the Blackmagic probes. Let me show you. Yeah, so here's one for rework. Yeah, so on the Blackmagic probe, you see there's this pad that you can remove and put on. It's pretty nice. The nice thing about it is it protects the connector also in shipment, so that the pins don't get bent and it doesn't get banged up. Yes, so yeah, we will need the datasheet, catalog page, footprints, double row, surface mount footprint. Bam, perfect. Yeah, we don't need the alignment pins, but I need to copy the footprint here. Recommended stencil layout. Oh, they even have stencil layout here. Very nice. Okay. Later. For now, we will just add this and call it X. Let's call it trig. Trig, and copy, and call it X CLK. There we go. So now we have trigger and clock on the connector. Very nice. All right. So these are the added new signals. And I think the next thing is to just start on the new front end. So we will be, so we leave the pull-ups because this is something the new parts don't have. Let's see, boop, boop, boop. There we go. Yeah, so we need a symbol for this, and this is a 4-part symbol, and the footprint is basically this DFN thing, and the ground pad is the ground. So the question is, I think I have a 4-part symbol with a shared ground pin. Oh, I'm curious how that works out. Okay, so that will be interesting. It's a little bit more complex symbol to build. So let's do that. Let's start general settings. So component name, how do we call it? So it says IP, does it have a series we can refer to? Nexperia, so NXP. Yeah, I think we just should just, so this is a 4 TTL 13, 4 TTL Z, and the difference is 54, 53, 52, and 51. And the difference is in the picofarad capacitance. So it's the capacitance difference. Which one did we choose? It's the 52. 52 is 30 picofarad. So it's 100 ohms and 30 picofarad. So it's the largest. No, that makes sense. 53, 52. It says 12 picofarad here. Oh, did DigiKey write something wrong on their description again? That's totally possible. Yeah, not that it really matters, but the interesting thing is that the 50x, it should be 50x. So, oh, and the datasheet is an IP425X TTL, and we need the number of the channel, so it has to be 4. So we will call this IP425X-TTL. -TTL, so we will call it dash, and then add dash, and then call it a 4. U and we have, how many units? We have 4 units in here. And units are not interchangeable. I don't know. I don't remember how this setting actually impacts things. Let's leave it at this. So we have unit A, and we start with unit A and do the drawing. So we have 1 input. Pin name would be, and the important thing is to then use the edit pins per part body style. Yeah, I have to look into that. Yeah, so I'm realizing that I have to so we did this, we did this, we did this. All right, I think I need to take a short break, and I will stop the stream really quickly, and I will come back in a bit, probably very soon. But yeah, I will take a little break here.